When we left off yesterday, I had asked you to do one thing of long division. Who was able to do that? Josh, you were able to do that, yes? What did you get for the first term of your long division? X squared for first term, very good. Okay, x squared. Because x goes into x cubed, x squared times, multiply that through, I get x cubed minus 2x squared. I am subtracting that bad boy, right? Everybody got their packets out. There you go. Distribute the negative. And I get 2x squared in the positive, yes? Now, how many times, Nick, does x go into 2x squared? 2x times positive or negative, sir? Positive 2x. So I'm going to put that up here. And when I multiply that through Mr. Smith, what do I get? Oh, before you answer that, though, John, what did I forget to do before? John. What's your name, John? What did I forget to do down here? Bring down the 0x. Very good. Okay, Mr. Smith, your turn. Multiply 2x through this term. We put that down here. So what is it? Minus 4x. There we go. There we go. I thought I had you there. Minus 4x. Okay. And then what? I'm subtracting that. Mr. McAlpine, how do I subtract this whole thing from this thing? Don't tell me the answer. Tell me how to do it. What do I have to do first? Boom, boom. Which, the academic language for boom, boom, boom is what? Distribute the negative. Thank you very much. Boom, boom, boom. All right, and then I get, what do I get? Let's see. Taylor, yeah, what do we get? Plus 4x, and then what do I need to do here, Abby? Put down the negative 8, very good. And then Christine, what goes into, how many times does x go into positive 4x? Plus 4. So then I get what? Jasmine? 4 times this guy. Very good. Very good. And then yes. Which is called distributing the negatives, right? There you go. There you go. And 4x minus 4x is 0. Negative 8 plus 8 is 0. And we have our answer. Okay, good. How many of y'all got this? I like the hands I see. Be loud and proud about that, though. Loud and proud. All right. Now, we are going to jump ahead because I want to find a universal. I want to find something universal. What do I mean by universal? What do I mean by universal? Important question here. I need everybody's attention on this. What do I mean by universal? Everybody say good morning to Mr. Olson. There you go. Thank you for being such a hospitable class. It is. But they're not answering my question. Why do I want a universal rule? What is the universal rule? Mr. Mullenberg, that is an excellent question. If I had x squared minus 16, how would the top factor? Close. X minus 4 and x plus 4, right? Okay. If I give you something that looks like this, but with numbers, you should be able to do it. But right now, what we're trying to do is we're trying to identify a universal pattern and express it algebraically so that you can use that every time you see something that fits this pattern. That's the goal here, okay? So, we're going to use the reverse tab. Now, let's do long division. Who likes reverse tabular? Who likes long division? All right. You can choose the method of your choice on your notes. However, we are going to do long division on the board. Okay? So we're taking, I'm going to do some x minus a is going into x squared minus a squared. Now, what do you think goes in the middle? I need a placeholder, right? Plus 0ax. 0ax. Bless you. So, just so you know, here's check this out. When I got a variable and a variable, here is the pattern for this type of equation. If I got, let's say I got x cubed, and I've got minus a cubed. Okay? This minus a cubed is really, it's really x to the 0 times a cubed. What is any number to the 0 power? Ooh. Who brought their calculator today? It's 1. Who does not believe him? Who does not believe Mr. Fox? It's easier to believe him, right? It's easier to push the I believe button than just believe him. Let's punch it in. Let's punch it in. We don't believe just because the gentleman is educated as Mr. Fox. Let's pick a number. What's 9 to, how do I do it on this? Here. 9 to the 0 power equal. It equals 1. Look at that. Look at that. How about 100? How about that to the 0 power? Okay. So, x to the 0, as long as x is not 0, that is 1. Mr. Peterson. So, this is also x cubed is the same as x cubed times a to the 0. You guys don't need to write this down. I'm just trying to show you a pattern here, okay? Now, this is plus 0. Actually, I don't like that. I'm going to put the a's. No, I put the a's last. A to the 0. And then this is plus 0 x squared a. And this is plus 0 x a squared. Okay, so the pattern here is the a's start with the 0 power and continuously step up. This is a to the 0. A is just a to what power, Giselle? What power is just a? It's the first power, right? And then a squared and a cubed. You see how it steps up? It starts from 0 and steps up. And then x starts at the third power and then steps down. So it's 3, 2, 1, 0. Mr. Jers, I will post this video this afternoon, okay? Shop! Ah! Hate it when I do that. Okay. Anyhow, does that make sense? This pattern. Where did my thing go? Alright. So, do you see where I got this guy? So now let's do some division. X goes into x squared how many times? X times. And then x times x minus a gives me x times x is x squared minus ax. Bless you. Now I'm subtracting this guy, right? Devin, what do I do here? One second, I want to ping on this right now. What do I do with this guy? Thank you. And then what were you saying again? So I got ax, and now your question, Mr. Smith. Did it really take a Kirk Cousins thing to distract you that badly? I wanted to show you the pattern of why I chose to put the a in front of the 0, or between the 0 and the x here. That was the whole reason. So you just didn't take my word for it.
How come it's not ax?
All right. So then I bring down my minus a squared. Now I see that look. How many times, Stephen? How many times does x go into ax? What do I have to multiply x by to get me ax? X times something, right? Yeah. Plus a, right?
Yeah.
And then x, or a times x is ax, and a times negative a is negative a squared. Plop, minus. Cora, how do I subtract these two? How do I take care of this guy? Distribute the negative. Well, what does that mean, Cora? What's this become? And then what's this become? And this? Good. So then I get ax minus ax gets me 0. Negative a squared plus a squared gets me 0. I'm done. Okay. Now, here's what I want you to do. Everybody got a table partner. Mason, Ty, work together. Everybody, in pairs of 2, work on this problem. Remember what I said. X cubed a to the 0, right? Plus 0 x squared a plus 0, hold on, x 0x a squared plus x to the 0. There it is. This guy here is that guy right there. All right. Survey. Quick survey here. Whose mind is blowing up when I show them this? Kinda? Okay. Definitely? All right. Just remember, if I got a to the 0, any number to the 0 power is just 1, right? So that goes away. We'll just pretend that's not even there because it's just 1 times x cubed. Okay? Same thing goes with my x, right? X to the 0 is going to be 1. Oh, except that should be a minus. I'm sorry. But 3, 2, 1, 0, 0, 1, 2, 3. That's the pattern of how this guy is built, and how we keep track of our places when we're dividing 2 variables to the 3rd power. Okay? So, work in pairs. Work in pairs, please. Ignore the area here. Completely other. How about you, Cora? You're Googling, so I'm assuming you did. Okay. Now, the only thing that's going is when you put the days in there. Well, that doesn't matter. So, A, B, doesn't matter, right? So, if you really want to x squared, plus, and then you got 0, 1. A squared, because remember the terms coming here right? So I got x cubed, and I got x to the nothing. Right? So I need to build down. I need to get that one. I need to have a square term. I need to have a term to the first order, and then I have to have an x to the 0, which is simplified to this minus 2, right? So this is here. These are what's playful. Now, why is it here? Remember, Alright, that's how I built it, okay? Alright, just a pattern. Then I divide that by 5. Is that e to the 0 is what?
Hoping I can have the same. Okay, quarter thing. You put 55 on my car.
So x goes in the x
How about
cubed
the
every time. X squared. That is x
We started with
squared.
50, then I'm back to 110.
And then x squared times s is what?
That's a quarter thing.
How many people got an answer here? Stylus. There you go. All right. That's what we're talking about. All right. Look, what'd you get?
I got x squared plus 8x plus 8 squared.
Plus what?
8 squared, right?
Who else got this for an answer? Cora was in Mr. Erickson's class yesterday and they did this, so good check. This is the pattern. So whenever I see Whenever I see this, I know the answer is that. We're going to skip the fourths. All right. So, if I wanted to simplify, let's look at letter B on the next page. It says, predict without performing division whether or not the divisor will divide into the dividend without a remainder for the following problem. So what does that mean in English? Yes, Jasper, do you have a question? Well, if you haven't done so already, finish the lesson 5 problem set. Exercises 19 and 20 in the problem set 1 through 4, 8 and 10. I will be assigning lesson 6 today. Lesson 6 is, and this will be due on, what's today, Tuesday? So lesson 6 will be due on Thursday. It will be the problem set number 1, letters A and B, and number 4. That will be the assignment due on Thursday. Alright, so we got a minute left. Alright, we will finish up lesson 6 tomorrow.